Welcome back to this explainer. Today, we're tackling a really fun data structures and algorithms challenge. It's LeetCode 3754. Concatenate non-zero digits and multiply by some I. So let's just dive right in and break down exactly how to solve this efficiently, step by step.
Take a look at this integer, 10,203,004. Notice how it's just full of zeros breaking up the meaningful digits? Our goal for this problem is to manipulate integers exactly like this one, or, even a simpler one like 5,001. We basically need to strip the number down, extract its core parts, and then perform some targeted math to transform it entirely.
So for our main example of over 10 million, our target output is exactly 12,340. But how do we actually get there, right? Well, we need to follow a strict, systematic set of rules to peel away all that noise and combine what's left over.
Okay, let's dive into this. Here is the absolute core of the problem, broken down into 4 really straightforward steps. We call this a simulation problem, because honestly, there are no crazy tricks here, just careful execution of the rules. First up, we filter out all the zeros. Second, we take those remaining non-zero digits and concatenate them, basically glue them together in their original order to form a brand new number. Let's just call that x. Third, we calculate the sum of those exact same digits. And finally, step 4, we multiply our new number x by that sum. It's just pure simple execution.
Now, to pull this off in code, we essentially have 2 primary paths we can take, the string method and the math method. The string method is what we might call the easy path, right? It relies on high-level built-in functions in your language to treat the number like text. The math method, on the other hand, is kind of the hacker path. It uses pure mathematical operations to extract the digits without ever converting the integer into a string format. And look, both work perfectly, but they teach us very different things about what's happening under the hood.
So let's look at the string approach first, because it is incredibly clean. We start with our integer, 10,203,004. Step 1, we just convert it to a string. Now it's a simple sequence of characters, which makes filtering an absolute breeze. We just walk through those characters and ignore any zero we see. That leaves us with a list of string characters, 1, 2, 3, and 4. We join them together, convert them back into an integer, and boom, that gives us 1,234 for our x variable. Then we just add 1 plus 2 plus 3 plus 4 to get our sum of 10. Finally, multiply that 1,234 by 10, and we land smoothly at 12,340. Now, I want you to look closely at this specific line of logic. When you use a built-in string join method on those filtered digits, you're completely bypassing the actual math of concatenation. Reading a string of digits as a base 10 integer just automatically handles all that multiplying by powers of 10 for you. Your programming language is doing all the heavy lifting here, connecting that abstract idea of gluing digits together directly into concrete numbers. It's super concise and, honestly, highly recommended for rapid coding. Now, what's really interesting about this slide is if you decide to take the pure math route, this specific formula is literally your golden ticket. X equals x times 10 plus d. This is the standard foundational way to append a digit to a number on the fly. By multiplying your current number x by 10, you're effectively shifting all of its existing digits one place to the left. Then, you simply add your new digit d, and it drops right into that newly opened units place. It's elegant, right? But wait, how do we actually get those digits, those d's, in the first place, without treating the whole number as a string? Well, we extract them manually. You can peel off the very last digit of any number by taking n modulo 10. That just gives you the remainder of dividing by 10. Once you've got that digit isolated, you permanently remove it from the original number by performing integer division by 10. This effectively chops off that trailing digit and sets you up perfectly for the next loop.
And this brilliantly illustrates how those math mechanics actually play out in a loop. Let's imagine a smaller snippet, something like 102. As we loop, we chop off that last digit. If it's not 0, we add it to our sum. Now, because we're extracting these digits from right to left, our new concatenated number is naturally going to build in reverse. In your code, you'd either just reverse it at the very end or use a multiplier to place the digits into their correct positional slots from the start. But the core engine here remains that simple, beautiful loop of modulo and division. Honestly, doing it this way proves you truly understand how positional numbers work under the hood.
Okay, but we also need to pause for a second and check for traps. What if our input number conceptually has absolutely no non-zero digits at all? Like, what if the input itself is literally just 0? In this explicit edge case, our filter would remove absolutely everything. That means our newly constructed number x is 0, our sum is 0, and well, 0 times 0 means the final answer is simply 0. It is such a great habit in DSA to always ask yourself, hey, What happens to my logic if my filter removes every single item?
So let's talk efficiency. For both the string and the math methods, the time complexity is big O of k, and the space complexity is also big O of k, where k is the total number of digits in our integer. Why is that? Because in both approaches, we're only looking at each digit a constant number of times to extract, filter, and sum them up. And even for truly massive integers, the actual number of digits is relatively small. So asymptotically speaking, both of these solutions are incredibly fast and perfectly optimal.
So the crucial point here is that this problem is a fantastic stepping stone for your DSA journey. By mastering it, you're really locking in 3 critical skills. First, digit extraction techniques. You're learning when it's better to iterate over a string versus when you should roll up your sleeves and use modulo math. Second, you're practicing how to apply filtering patterns with a specific condition. And third, you're mastering that positional number building formula that literally lets you construct integers out of thin air.
Once you're perfectly comfortable extracting, filtering, and rebuilding numbers using these techniques, I promise you a whole new tier of algorithmic challenges is going to open up for you. You've got the solid foundation down now, so the only question left to ask yourself is, are you ready to tackle complex, multi-pass digit transformations next? Thank you so much for exploring this with me on this explainer, and as always, keep learning.